Welcome back to RoboFication for AI Safety Critical Systems. I'm Mike, your systems engineering expert. Today, we're getting into a crucial topic: industry standards for AI in safety critical systems. These standards are not just technical checklists. They're what ensure the safety, reliability, and accountability of systems like self-driving cars, drones, medical devices, and more.
And I'm Sophia. AI is changing the game across industries, but when AI controls a safety-critical system, the stakes are much higher. Today, we'll explain the key industry standards that help ensure AI systems don't just work, but work safely.
Let's start with the basics. Safety critical systems are those where failure could result in serious harm, injury, or even death. Think about the braking system in a car, autopilot in an aircraft, or even a robotic surgery system.
Exactly. Now, with AI in the mix, things become more complex. AI systems can sometimes behave unpredictably, especially if they've been trained on data that doesn't fully reflect real-world scenarios. AI can adapt, but sometimes in ways we don't expect. That's why these systems need rigorous industry standards. So, Mike, let's break down the standards used in different industries. What's happening in the automotive sector?
Great question, Sophia. In the automotive industry, the key standard is ISO 26262. This international standard focuses on functional safety and guides the entire lifecycle of safety-related systems in vehicles. It emphasizes hazard analysis, risk assessment, and developing safety measures.
And don't forget SAE J3016. This is where we get those 6 levels of vehicle automation, from basic driver assistance all the way to full autonomy.
Exactly. And if we go beyond national borders, UNIS WP.29 is a United Nations regulation providing global safety guidelines for automated vehicles. This standard sets the baseline for AI-driven features like lane keeping and emergency braking. In aerospace, the stakes are even higher. We rely on standards like DO 178C, which is all about software safety certification for aircraft. This standard ensures that any AI system on board follows strict safety protocols.
And there's DO 254 for hardware. It complements DO 178C, ensuring that hardware and software work together safely. If a self-flying drone malfunctions, you want to be absolutely sure it's following the safest possible protocols.
Exactly. And let's not forget ARP 4754A, a standard that covers system development for civil aircraft. It's all about making sure everything, from AI-driven systems to mechanical components, works together seamlessly.
What about the defense industry? AI is increasingly used in military drones and threat detection. How do they ensure safety?
The defense industry has MIL STD 882E, which provides guidance on system safety for AI-driven military systems. There's also NATO STANAGs, which focus on ensuring interoperability and cybersecurity between different countries' AI systems.
In healthcare, standards like IEC 62304 regulate the life cycle of medical device software, including AI systems. And ISO 14971 ensures that risks are identified and controlled for medical devices, making sure they operate safely.
And in the US, FDA guidelines are incredibly important for AI-based medical devices. They've created good machine learning practices, GMLP, to make sure that AI continues to operate safely even after deployment.
So, how do we take AI from concept to a certified safety-critical system?
It all starts with requirements definition. You need clear, precise requirements for both functionality and safety. Then comes hazard analysis, and this is where we use techniques like system theoretic process analysis, STPA, and failure modes and effects analysis, FMEA, to anticipate potential failures. While FMEA is a well-established method, STPA is particularly more suitable for AI and software systems compared to older techniques. STPA helps us account for complex interactions and unpredictable behaviors in AI systems, providing a more robust approach to identifying and mitigating risks.
Right. And then during design and development, we build AI systems with transparency and explainability in mind. Once the system is ready, it undergoes extensive verification and validation testing. This includes simulations to test edge cases and unpredictable scenarios.
Finally, certification involves rigorous review by regulatory bodies. They audit the system, review documentation, and monitor performance post-deployment to ensure ongoing compliance.
But it's not all smooth sailing. There are big challenges in certifying AI systems. For one, many AI models are like black boxes. They make decisions, but we can't always explain how they came to those decisions.
Exactly. That's why explainability is becoming a major focus. Regulators are pushing for explainable AI, XAI, so that we can understand and trust how AI makes decisions.
And then there's dynamic learning. AI systems that learn and adapt over time can pose new challenges. The certification process has to keep up with these changes to ensure the system remains safe.
Another challenge is data quality and bias. If an AI system is trained on biased or incomplete data, it can produce unsafe outcomes. Ensuring high-quality data is a major part of certification.
Looking ahead, standards will have to evolve too. AI systems are becoming more adaptable, so we'll need adaptive standards that allow for continuous learning post-deployment.
True, and there's a growing emphasis on global harmonization, aligning standards across countries and industries to ensure consistency.
And we can't forget cybersecurity integration. As AI systems become more vulnerable to attacks, cybersecurity must become part of safety standards.
So, AI is reshaping safety-critical systems across industries. But without industry standards, we can't ensure safety, reliability, or compliance. It's these standards that allow us to trust AI in high-stakes environments.
Absolutely. By adhering to these evolving standards, industries like automotive, aerospace, defense, and healthcare can unlock AI's potential while keeping people safe.
In our next episode, we'll be discussing integrating human factors into AI systems engineering, exploring how AI systems interact with human operators to ensure safety and usability. Stay tuned for more.
Don't forget to subscribe to our YouTube channel at RoboFication.
Follow us on LinkedIn and X at RoboFication.
And share your thoughts below. We'd love to hear from you.
Thanks for joining us on RoboFication for AI safety critical systems. Let's keep building the future together.